Question number B. Water flow out from horizontal at the end of pipe. So this is the pipe, meaning this is a water direction, water flow at height of pipe from the ground surface is 52 centimeter. If the horizontal before it hits the floor is 10 and 100, so this is 100 centimeter. And calculate the velocity of the water at instant lift, so meaning what is the initial velocity here, because the direction of the velocity is a horizontal direction. Here is we have only ux, no direction for the velocity vertical or uy. And the information given by the questions is 52 high, and the distance here horizontal is 100 cms. And what is the ux here? So to find the value of ux, because the magnitude of the ux at the each point here, they say this is x, they say ux1, ux2, and this is ux3, because the direction of the ux not influenced by the gravity g 9.81, the value of the ux is always constant, right? For the ux, meaning the ux1 is equal to ux2 and ux3, right? So now you can use the value of the first is 100 centimeter here. From the formula, velocity or u, this is direction for the horizontal or x-axis, is equal to the distance or displacement direction x or horizontal divided by time t. For the t here is the time taken for the object from the initial position, right? Initial position is start with water flow horizontal at the end of pipe, so this is initial position, and this is final position. But if you can compare the time taken from the vertical direction here, let's say this is T1 from the top level to the ground level, and the time taken from the projectile path here, let's say this is a time taken projectile is time 2, time 1 is equal to time 2, meaning the same time for the T1 and the T2. So you can use to calculate the T1 here, because the T1 is referred to the time taken for the object from the initial to the final position. So to calculate the T1 or the T2, you can use the equation or formula S for the vertical, meaning Sy is equal to Uy t minus half gt square, right? Now Sy here is because direction for vertical is 52, right? 52, but the direction of the water to downward, meaning you have a because this is centimeter, convert to meter is 0.52, and uy here, uy meaning the initial velocity for the water flow is uy is equal to 0, because For the initial position, only velocity for the x direction. So meaning here uy is equal to 0. So meaning we have half and the g is constant 9.81, and this is the value of t. So now you can use the calculator to find the value of t here is 0.33 second. So next you can use the value of 0.33 second to the equation here, because the displacement or distance is 100 and the time taken is a 0.33, and you can find the value of initial value or ux is equal to 3.03 meter per second. Alright, that's all. See you on the next video. Thank you.